So the formula for Graham's law is the velocity of substance A is inversely proportional to the molar mass of substance A. You can compare that with the rate of substance B, or the velocity of substance B, which is also inversely related to the molar mass of substance B. Let's do number one together. A sample of hydrogen. Okay, this is hydrogen gas, which means it's diatomic. Remember your diatomic molecules. Hankel-Briff. Okay, that spells Hankel-Briff. If they say they're in a gas phase, they're all diatomic, 2s. Don't forget to double the molar mass. Noble gases, for example, helium, neon, argon, are not diatomic. Okay, because they're noble gases, they only need one, they don't bond. So a sample of hydrogen gas effuses through a porous container 9 times faster than an unknown gas. Okay, so let's go ahead and look at this. So I'm going to put the velocity of whichever is faster on the top. Okay, the velocity of hydrogen gas is equal to the molar mass of hydrogen gas. Okay, which is inversely proportional to each other, right? Now, if you compare that to the unknown gas, this we'll call that X. It's also inversely to the molar mass of X. For all these problems, I will be looking for this formula. You must write this formula for every single one before you plug in. Okay? So the plug-in looks like this. VH2 is 9 times faster than the unknown. So this number is 9.0 times faster than the unknown gas. So Vx is 1, VH2 is 9. Okay? Equals to the molar mass of H2 gas goes in the bottom. They're inversely related. So H2 is 1.008 times 2 is 2.016. Okay? Estimate the molar mass of the unknown gas. So this is unknown. I'm sorry, it should be red. It's the unknown gas X. And the molar mass is the square root. This is a very powerful problem. If you can see how many times faster one is from the other, you can tell how much it weighs, which is something cool because you can't really see it. The easiest way to solve this problem, you're trying to solve for X, is just to square both sides. So if I square this and I square this, I will get rid of the square root. So it would be 9 times 9 is 81 divided by 1 is equal to X over 2.016. Okay, so cross multiply. X is equal to 81 times 2.016, which is equal to 160. And it's molar mass. So if this is grams per mole, then this is also grams per mole. And that is that number. Okay, let's try one more. Okay, compare the rates of effusion. What that means is how many times faster is one than the other. You have carbon dioxide, which is CO2, and you also have hydrogen chloride, which is HCl. Okay, so I'm going to get the mass of CO2, which is 1 carbon is 12.01, 2 O's is 16 each, so 32.00, so it's 44.01 grams per mole. That's CO2. Okay, HCl, H is 1.008, Cl is 35.45. So it is 36.458 or 46 grams per mole. Okay. What I'm going to do is I'm going to pick the lighter molecule to put on top. It'll just make my number easier here because it'll be faster. So my lighter one is HCl. This is lighter. We'll use blue for that one. No, blue. That one's lighter. So I'm going to use, again, we will always write this formula. VHCl is equal to the square root of the molar mass of HCl. Okay? Then putting the heavier one in the bottom, velocity of CO2 is heavier, is inversely proportional to the molar mass of the CO2. Okay, there's my formula. Again, I will not accept it without that. Then my plug-in, velocity of HCl is unknown, but it's inversely proportional to 36.46, the square root of 36.46 grams per mole. Okay, then the velocity of CO2 is inversely proportional to 44.01 grams per mole. If you divide those, you're going to get 1.099. Okay, because that has 4 sig figs, 4 sig figs, 4 sig figs. So that number means whatever is on top, which is HCl, is 1.099 times faster than CO2. In other words, it's 1.099 to 1. So my answer should read HCl is 1.099. This is first. HCl is 1.099 times faster than CO2. And that's how you should report your answer. Okay? If you happen to mix these up, like you put the HCl in the bottom, you're going to get a number that's less than 1. So you would say CO2 is this many times slower than the other one. But it's still correct. It just doesn't make sense how many times slower. This makes sense. It's 1.099 times faster.